So in your previous class, we had discussed about types of WAN technologies, type of WAN topologies, like hub and spoke topology, full mesh topology, partial mesh topology, and WAN connectivity, like laser line connectivity by using optical fiber cable, MUX, modem, copper wire, these things, and DCE DT devices, data communication equipment, data termination equipment, master and slave, which is generating the bandwidth, which is accepting the bandwidth, these things. And WAN encapsulation methods like point-to-point protocol and SDLC. Point-to-point protocol is open standard which can support for authentication. SDLC no authentication. It's a Cisco proprietary protocol. WAN interface configurations like how to assign IP address to WAN port and no shutdown, encapsulation, clock rate. So these things we discussed. And WAN troubleshoot like up status is admin down, protocol down. Status is down, protocol down. Status is up, down, like up, up. These things and verification, like how to check the link connectivity and ping commands, right? So these are the discuss we have yesterday. And today, let me continue with, so here I have one scenario. Let's consider this is your branch 1, branch 2,
Balu,
and head office. Yeah,
Balu, before you were starting, I have a doubt.
yeah, please.
Yesterday, as we discussed about that one WAN connectivities and interfaces, uh, um, that routers I am getting overlapping.
Yeah. See, in R1 router or R2 router, any router, if fast Ethernet or serial interface. See,
Mhm.
for S0, if you are using 172.16.0.2, now on the same router for another interface, we cannot make use the same network. See, if you use 172.16.0.3, now we can get IP address 172.16.0.3 is overlapping on S0. So because of 172.16 network, you already used on S0, right? So for another interface, we have to use a different network. So 172.17.0.1, you can use it. Overlapping means in one router, in different interfaces, you are maybe running the same network address. That is the error. Okay. Yeah. So see here, scenario here, branch 1, head office, and branch 2. So now we know how to assign IP address to LAN ports. All routers, LAN interfaces, we know clearly discussed about how to assign IP address and how to activate it. And even serial ports also, like branch office 1, S0//0, S0/0/1, towards head office to branch 2, 0/0/0, 0/0/1, right. But our main target is how exactly branch office 1 LAN users, head office LAN users, and branch office to LAN, how to enable LAN to LAN communication. So yesterday, day before yesterday, we just discussed how to assign IP address to interfaces, the LAN interface and WAN interface. But what is our today target is traffic has to move, traffic has to enable, the communication has to enable from LAN to LAN communication. Now, when exactly traffic communication enable from branch 1 to branch 2? A data traffic has to move from branch office 1 to branch office 2 or head office. And head office should give reply back. See, what do you mean by communication means like from your mobile phone, your phone, to Facebook server fb.com. Like if you open the Facebook page from your mobile phone, traffic is being generated. The traffic is going to Facebook server, and Facebook server gives a reply back. Then you can get your Facebook page, right? Means what exactly happening here? Your IP traffic is moving from your mobile phone to Facebook, means destination, and destination device giving reply back. Then communication will be happened. Same like here, branch office one, head office, or branch office one, branch office two. How they can communicate means your IP traffic has to move from one LAN to another LAN. I mean one network to another network. So this process we call IP routing. IP routing. IP routing is a process of moving IP traffic from one network to another network. And when IP routing is moving, like IP packets is moving, it involves two basic activities. The first one is finding a best routes to reach a destination, forwarding packets through these best routes. So two basic activities in IP routing. You can see this IP routing. It is a process of moving IP packets from one network to another network. So when traffic is moving from one network to another network, it involves two basic activities: determining the best paths, forwarding packets through these best paths. Okay. So finally, how to enable LAN to LAN communication means we need to configure what? IP routing. So to enable IP routing, so first you need to follow some IP conditions. So what is IP conditions? Let's say in branch one, user one, computer, user two, and three users. Similarly in head office also, user one, user two, user three, three users. Branch office two, three users. So IP conditions here. You know what is IP conditions is? Condition number one, head office router fast Ethernet IP address should be in the same network as the head office LAN. And similarly, branch office router fast Ethernet IP address should belongs to same network as the branch office LAN. This is a condition number one for IP routing. So what is the condition here telling is, listen everyone, listen carefully. First condition is head office router fast Ethernet IP address and LAN users IP address should be in same network. It can be class A private IP or class B private IP or class A private IP. So condition is what? Whatever IP address you're using for head office fast Ethernet port, the same network should be in your LAN users also. Like my example, I am writing here, head office fast Ethernet interface is 10.0.0.1. Now LAN users can assign 9.0.0.2? No. Because of fast Ethernet IP is what 10.0.0.1, then your end users also should be in the same network. So 10.0.0.2, 10.3, 10.4. This is the condition. So same, like similar condition on branch 1 and branch 2. Say in branch office 1 have assigned IP address 192.168.1.1. For LAN users, can I use 192.168.4.10? No. You're using 1.1 for router LAN interface. Then your PCs should be in the same network, like 1.2, like 1.3, 1.4, I mean 192.168, like this. Similarly, branch office 2 also, for branch office 2, I'm making use 2.1, then end users 2.2, 2.3, 2.4. This is a first condition. All of you, is it clear for condition number one? Router LAN interface and LAN users IP address should be in same network. Even you can check your computers IP config. See what is my PC IP address? 192.168.0.7. Router IP address 0.1. So PCIP, router IP always should be in same network. That is the condition number one. So clear everyone?
Yeah, well,
Yeah. Condition number two. Serial interface IP between head office and branch office should be in the same IP network. So what is the condition number two? Serial interface IP between branch office 1 and head office both point to point connected, like so both are directly connected. This both interface should be in same network IP address. So in my case, in my example I'm using here, for branch office 1 serial interface, say 172.16.0.1. For head office S001, which is directly connected to branch 1, towards connect to branch 1, here can I use 172.18.0.2? Can I use this IP address?
Yeah.
No, no, sir. Can't use.
No. Condition is what? Serial
Head office
interface
and branch
IP between head office and branch office should be in the same IP network.
same IP.
So 172.16 means here also should be
Yeah, one
172.16 dot 0.1 here means you can use 0.2 or 0.3, 0.4, whatever. This is the condition. Similarly, head office serial 00 and other end, which is point to point connected. Branch to serial, both should be in what? Same network. Then can I use 172.16.0.3? Here 172.16.0.4.
No,
Why?
overlapping the same network.
overlapping.
That is the point. Why? Because see the last condition here, condition number 4 is all interfaces of your router should be in the different IP network. All interfaces of your router should be in the different network. So if router has a three interfaces like LAN interface, WAN interface 1, WAN interface 2, it's Ethernet, S0 and S1. So all interface of router should be in different IP network. So S0, I'm using 9.1.1.1. S1, can I use 9.1.1.2? No. Overlap will come as well. I'm using 19.1.1.2. Yes. For Ethernet, can I use 9.2.1.1? No. Already S0, 9 dot network is right. So let's say 90.2.1.1. So all interface of router should be in different network. So 172.16 already you have used for head office S001. Then how we can use 172.16 again the same router? No. So have to change the IP address here 172.17.0.1, but condition is other end should be in same network. So 172.17.0.2.
But
Right,
my
yeah,
all
please.
routers are different networks. I'm getting overlap here.
Which router you have configured? Router name
Router name R1 and R2 only. I
R1.
can't.
The R1, where you are getting overlap in R1 and R2?
R2.
R2. Okay. R2, how many interfaces is?
Two interfaces is there.
LAN interface and WAN interface, right?
Yeah.
Okay. What is the LAN interface IP address you have assigned? We have used
I used one 172.16.0.2.
for, for fast Ethernet. R2 fast Ethernet.
Yeah.
172.16.02. Okay.
0.2. Yeah.
Serial.
Serial serial 0/0/1. I used 172.17.0.2.
Okay.
And R2 to R3 serial 0/0/0 172.15.0.1.
Okay. Then all on the different networks.
Yeah,
So where you are facing like overlap command in R3 or R1 or R2? Where exactly you are getting?
R2 I'm getting. R1 to R2.
So what is R1 LAN interface?
R1 LAN interface is 17.16.01.
Serial?
Serial 172.17.0.1.
Conditions okay, but somewhere you're doing the mistake actually. Instead of 172, maybe you're
Mm-hmm.
using 17, I think so.
Okay.
Just you can check it. As per these conditions, everything is okay.
Okay.
R1 and R2 have same network 122.17.
Yeah, 172, 17. These WAN links should be in the same network.
Okay. Serial 0 and serial 1. Okay.
Yeah.
Okay, I can try it one more time.
Yeah.
What about that fast Ethernet? Both networks are same now, no problem.
Different. This is 17.16.0.1. This is 172.16.0.2.
Okay.
No. 172 for this one also. R1 LAN.
Yeah, it should not be like that actually, you know.
All we should
Oh,
be
it
all
should not be
maybe
like that.
Yeah, 172. It should
Yeah.
not be like that because see the condition here, condition number 3, head office LAN and
Mm-hmm.
branch office LAN should be
Indifferent IP
in
network.
different IP network. So
Okay.
172.16 you have used here in R1. In
Mm-hmm.
R2 also 172.16, how can come use? No, both should be in different network.
Okay.
Yeah.
So for WAN interfaces, it can be in same net.
WAN interface should be in same.
Okay.
LAN should be in different. So why LAN should be in different network? What if we use the same network in the both LANs R1 and R2 LANs? Example,
we already used a fast Ethernet between LAN and PC, you know. Then why? So that's why we can't
yeah,
use.
what is the problem we'll face if we use R1 and R2 for LAN, same network if we use. See here fast Ethernet, here fast Ethernet. I'm using here 192.168.1.1 and here I'm using 192.168 1.1 254 and end users are 1.2, 1.3. Here I'm using 1.100. Here I'm using 1.101. See, problem is, say 1.2 user is trying to communicate with 1.100. Packet is being generated. What is source IP? 192.168.1.2. What is destination IP? 192.168.1.100. Now source IP, destination IP, both are in same network or different network? Source
Same.
IP address,
Same.
destination IP, both are in same network, right? Then what my
Same
PC is
network.
understanding means, oh, my destination is in a within my LAN only. So my destination is not in outside. So my destination device in LAN only. So my PC is going to looking into LAN only. So this packet will never go to outside. Because of destination, the same network, right? Then what my PC will thinking about? Okay, so gateway is not required because of destination, the same network is looking into network LAN only. So packet will not go to outside. So no communication. It should be different network. Then if it's a different network, 8.100, now packet will go to router and router will check the routing table and packet switching, packet forwarding. It can be communicated. Is the logic clear? Now, once again, you can read the all conditions. All interface of router should be in different network. Head office LAN, branch office LAN should be in different network. Serial IP interface between head office and branch office should be the same network. Router LAN interface IP and LAN users IP should be in same network. Is the four conditions in this diagram is satisfied or not? Can you please check and tell me? So branch 1 LAN network is 192.168.1.0. Head office LAN 10.0.0.0. Branch 2 network 192.168.2.0. So three branches, different network I have used. That is condition number 3. Head office LAN and branch office LAN should be in different network. So condition number 3 is okay. Now all interface of router should be in different network. Like in branch 1, how many interfaces there? In branch 1, you have two interfaces,
Two
FE00,
interfaces.
S00. So two interface should be in different network. So one interface I have used 192.168, other interface I have used 172.16. Condition is satisfied. The head office, how many interfaces there? S001,
Three.
S000, FE00, three interfaces. Three interface should be in different network. So 172.16, 172.17, and 10.0.0. Different network have used. Condition is satisfied. Now branch office to have it two interfaces, S001, FE00. Two interface should be in a different network, 172.17, 192.168. So condition number 4 is also satisfied. The condition number 2, serial interface IP between head office and branch office should be in the same network. Mean point to point, 172.16.1, 172.16.2. Similarly, 172.7.1, 172.17.2. Condition number 2 is also okay. Condition number 1, fast Ethernet IP address and LAN use IP address should be in same. 10.1, 10.2, 10.3, 10.4. 192.168.1.1, 1.2, 1.3, 1.4. Here 2.1, 2.2, 2.3, 2.4. So now you tell me guys, is the condition is satisfied or not? Yes, please.
Branch office 2, 192, 168, is it same network?
Branch office 1.1, branch office is 2.1. This is 2.1 now. This is 1.1, different networks. No, what is the question exactly, Mahesh?
No, I'm thinking like these two are in same network or
Branch 1,
192 and
branch 2.
yes.
Yeah, both should be in different network, and I have used a different network only.
Okay.
Yeah, this is, see, class C IP address. N, N,
Yes,
N,
right.
N, H. Three
Yeah,
networks. Yeah.
different. Okay.
So clear for everyone? All the conditions?
Yeah.
Yeah. So I request to everyone, you also make a diagram for three routers and you try to assign your own IP addresses, your own examples. So I have used 192.168.10.172.16, right? So you design your topology with your own IP addresses based upon the conditions. Then you can have some practices actually. Not now, later. Okay, right.
You have to use only private IPs for all this.
See, for practices, they can use any IP addresses.
Okay.
Private IP, public IP, any IP address practices. But in real time, for the LAN ports, we use private. The WAN ports is public.
Okay.
Yeah. So conditions is okay. Now, types of routing. So what is routing? Routing is a process of moving IP traffic from one network to another network. The process can done the three ways. I mean, we can move the packets. We are moving the traffic from one network to another network in three methods. One is static routing, dynamic routing, and default routing. Three methods is there. Okay. So first let me continue with static routing. What is static routing is? Before that, I want to tell you one thing. So routers are intelligent devices. What router will do? What is the function of router? Functions of a router. Remember, we discussed
Packet forwarding.
packet switching, packet forwarding. Okay. Next, inter-network communication, best path selection. So how exactly router will enable two or more different logical networks communication? You know how
Packet
router will find
forwarding.
the best path. You know how router packet forwarding is done. You know how router packet switching is. Like entire router mechanism will be happen based upon the routing table. Router maintains one table called what? IP table, or we can call routing table. So based upon the routing table information, router will enable two or more different logical networks communication. Based upon routing table information, router will find the best routes. Like router will forward the traffic through best routes. And based upon the routing table information, packet switching and packet forwarding, entire router mechanism, router intelligence happening based upon what? Routing table. If router is not maintaining the routing table, then router is not a router, it's a dummy device, no intelligence. So complete router depends upon what? Routing table. So that routing table we need to be understand very clearly what information routing table contains and what will be what parameters you need to focus on the routing table, how it is updating. This is very, very important, guys. So every router maintains routing table. Let me take one clear diagram. Yeah, you just please check the conditions here, IP conditions, routing conditions satisfied or not. Yes. Is the condition satisfied?
Yes.
Yeah. Okay. Right. Branch office 1, head office, and branch office 2. Branch 1, 1.1, 1.10, 1.20, 1.30. Head office 10.0.0.1, 10.10, 10.20, 10.30. 2.1, 2.10, 20, 30. WAN links 172.16.1, 172.16.2, 17.1, 7.2. Conditions okay. Now every router maintains a routing table. Branch office 1 is the routing table. Head office routing table. Yeah, every router maintains what? Routing table. Here, let's fetch for routing table and branch office to routing table. Let me design same topology in the packet tracer. So 2811 routers I'm using here. R1, R2, R3. Switch 1, 2, 3. End user devices. 1, 2, 3 devices for each LAN. The connections. Like WAN serial ports I'm adding here. Powered off. WAN interface card for second router. Now connections. From R1 S000 to R2 S001, S0002, S001. LAN network. Okay. The configurations. First router 1. I'm just configuring only the host name of the devices. As per our diagram, host name is branch office 1. Next router, host name is head office. Host name branch office 2. See, every router maintains a routing table. First, branch 1 routing table. By default, routing tables are empty. We don't have any information in the routing table. By default is empty, guys. When you purchase a brand new router. So now, if you assign IP address to fast Ethernet, interface fast Ethernet 0/0, IP space, address space, subnet mask, and No shutdown. So once you press the no shutdown command, and immediately we'll get one notification message, right? What is that? Change state to up. So whenever if your fast Ethernet port is link is up, then immediately this network ID information will update your routing table. So in your branch office one, how many interfaces you have? Two interfaces. If two interfaces IP is assigned and status is up, then two interfaces network ID information will update to routing table. In head office, how many interfaces you have? Three interfaces. If three interface IP is assigned and link status is up, then three interfaces network information will be updated in your routing table. Like this. See, if it is a upstate, then the routing table you can get 192.168.1.1 is a IP address, 1.0 is a network ID, is directly connected. C means directly connected to which interface? FE 0/0 interface. This network is connected. Like in head office router, 10.0.0 IP address assigned and status is up. Then in head office router, you may get like 10.0.0.0 is directly connected to which interface? FE 0/0. Like your branch office to router, IP is assigned and status is up. Then what is the information here you can get? 192.168.2.0 directly connected to which interface? FE 0/0. Let me check practically now. So present in branch 1, show IP interface brief, like all interface IPs unassigned status is admin down. Now if you open the routing table, we don't get any information. Show IP route is a command to enable to open the routing table. So to check the routing table, show IP route is the command, enter. So we don't have any information in the routing table. So if you assign IP address and if you make the link is up, then routing table is updated. Let me assign IP address to fast Ethernet interface fast Ethernet 00 192.168.1.1 255.255.255.0 no shutdown. So we got up message, right? Now if we check routing table, back to privilege mode, show IP route. Say we have update. C means what? Directly connected. Which network 1.0 is directly connected to which interface? FE 0/0. Okay. So like that in router 2 also, which is head office. Interface fast Ethernet 00 IP address 10.001 255.0.0 IP is assigned. Can I get update in routing table now? No.
No shutdown,
IP
no
should be
shutdown.
assigned and your port should be active. Then only in the routing table update we can get. So no shutdown. Now if we check routing table, what is the command? Show IP route. Enter. Have you seen this now? Directly connected. 10 dot network is directly connected to which interface? Fast Ethernet 00. For last branch office 2. Interface fast Ethernet 00. IP address 192.168.2.1. So 255.255.255.0. No shutdown. Show IP route. So we'll get 2.0 network is directly connected to fast Ethernet. The same information I have updated here, guys. Clear? Right now, you tell me what if your WAR links is also upstate, like branch 1 S00 link is up, and head office S001 is also up. IP is assigned and link is up. Now tell me update in routing table of branch 1. 172.16.0.0 is directly connected to which interface? S000 interface. In head office routing table, 172.16.0.0 is directly connected to which interface? S0001 and 172.17, three interface in head office, is directly connected to which interface? S0000. Now branch office 2, 172.17.0.0 is directly connected to which interface?
001.
S001. Yeah, S0/0/1. So this is how your routing tables will be updated when you have assigned IP addresses to your local interfaces. Okay. Let me assign IP address to for WAN links also in 3 routers. Serial 00,
Balu,
172. Yeah,
I heard out. Do
yes.
we have to do encapsulation here again?
Encapsulation, the Cisco routers by default SDLC will work.
Okay, we don't need to do PPP.
No need a PPP.
Okay.
Yeah. The last router, branch 2, serial port. Yes. So 3 routers is configured. Let me check routing table in branch 1. Show IP route. So we have 2 directly connected networks, 172.16, 192.168 on S00 fast Ethernet. Head office router. What's the command to check routing table? Show IP route.
Show IP route.
Yeah. Now here, 10 dot network, 172.16, 172.17. So which network on which interface is there, we can easily understand. 172.16 is on S001. 172.17 is on S000. So 10 dot network on your LAN port, fast Ethernet, is all are connected, directly connected. C means what? Directly connected. Last branch 2, show IP route. So here also we have 2 directly connected networks. Clear? Okay.
Balu,
Yeah, please.
in packet tracer, there is an option to see without typing a command. When I place the mouse on the router, it shows whether it is status is up or not. No?
Yes.
It's showing a table directly on that
Not table, just will show the link
status.
status. Yeah.
Link status.
If you use a cursor and router, then it shows a up or down.
Yeah.
So this is not recommended. Like better to go for log into router and check the routing table. We can routing table, we can have some information.
Okay.
It's only for reference.
Yeah.
Yeah. Okay. Now, main point is here, we need to implement routing part, right? Means traffic has to move from one network to another network. So branch office one LAN users, head office LAN users should communicate. When communications can happen, if traffic is moving from one network to another network and reply will come back, then communication is enabled, right? Let me check it now. A simple example. Branch office one first user is communicating with head office first computer. Repeat, branch one first user is communicating with head office first computer, which is a source and which one is the destination? Branch one
Branch
first
office
device is
one
what? Yeah,
source
source. Head office first device what?
destination.
Destination. So from source side, data traffic is being generated, right? Now this data packet from source device to destination device, it has to be cross how many interfaces? Your data packet, IP packet from source to destination device, how many router interfaces it has to be cross?
Two.
From source to destination.
F00 and 4.
There's how many interfaces total? From source device to destination device to move the IP packet, how many router interfaces it has to be cross?
4. I'm wrong.
4. Which interfaces?
F0 by F0, fastnet 0
This
by 0,
LAN
serial 0 by 0, 0
001.
by 1, and F0 by 0.
Yeah. So branch 1 LAN interface, branch 1 serial port. Head office serial 1 and head office fast Ethernet, right? 4 interfaces. Now, to move this IP packet from source to destination, it has to be cross 4 interfaces, right? The main point is these 4 interfaces network information should be available in the routing table. Then only packet will be moved. And next point is in all 4 interfaces, link status should be up. The link should be up and all 4 interfaces network information must and should be available in routing table. If any one of the interface link is down or any one of the interface network information is not available in routing table, your router simply drop the traffic. Before we discussed how router will work, how router will function based upon the routing table information. In the routing table, if there is no information, simply drop the traffic. Let me check it now. Now data packet is being generated. Come to fast Ethernet port first. Okay. Now fast Ethernet state is what? Upstate. IP address 192.168.1.1. So do you have information in the routing table about 1.1? Yes or no?
Yes.
Yes, 1.1 means what? 1.0 network information is available, right? Yeah. Now your packet is switching to serial port. Now what serial port's link status? Serial port is upstate and serial port IP address is what? 172.16.0.1. Do we have this information in the routing table?
Yes.
Yes. Now what serial port is doing is packet is being forwarded to head office serial 1. So head office for serial 1 link is up, but IP address 172.16.0.1, do you have information in the routing table? Yes or no?
Yes.
Yes, 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 yes.
Yes, is there. 172.16.1, 172.16.2, both are belongs to same network. So we have network ID there. Yes. Now S001 packet switch to fast Ethernet. Fast Ethernet link is upstate, but 10.0.0.1, do you have this information in the routing table? Yes or no?
Yes, sir.
1000 information is available in the routing table here?
No.
No.
No, sir.
No, 1000 information is not there in the branch 1, right? Then your traffic is drop here.
But it's available for interfaces, right?
Where?
Is F001 S/00/0
See,
S/001 and F00, right?
yes. So means 4
If
interfaces, 1.1
yeah,
information is available in the routing table. 17 to 16 network is available in routing table. Now what
okay.
about this 10 dot network? Where is 1000 in routing table? It's not there, right?
Oh,
Then your
then
traffic is drop here.
okay.
All of you are getting my point?
Yeah.
Madhu.
Yeah.
Hey, this is a source. You need to think about from the source. From source, traffic is moving to destination. This is your destination. From
Mm-hmm.
source to destination, how many interfaces the packet has to be crossed? 4 interfaces.
4.
So 4 interfaces network information must and should be available in the routing table. That's the point.
Yeah, I got it, that one.
Yeah. So 1000 information is not available means your traffic is drop here, then no communication. Then how your data traffic can reach to 10 dot network destination PC? This 1000 network information manually we need to be update in your routing table. So I'm going to update in my routing table manually 10.0.0.0 information in routing table. So your destination network information, if you are updating manually in your routing table, is nothing but what? Static routing.
Okay.
Static routing, your all destination network IDs in your routing table as the network engineers, we need to be update manually. Okay. So right now,
Yeah.
In
yeah,
same
10
way,
0,
Now we need to update that to static.
yes. So 10
in,
0 network information is automatically updated and manually we need to update.
manually.
Manually.
Manually. Manually means by using which method?
Static.
Static. So your
Start.
code will be shows as a yes here. So based upon the codes, we can understand which network is statically updated and which network is directly connected and which interface is directly connected. So lot of information in the routing table, guys. Every parameters, every point is very important here. So which network is directly connected, which network is statically updated, which network is dynamically updated. That information also will be shows the codes. Okay, right. Now 10 dot network I have statically updated, manually updated. Means this my IP packet can reach to destination now.
Yeah.
We have to update that 192.168 in table 2, no?
Very good, Shivateja.
Yeah.
Exactly. See now you have updated 10.0.0 in branch 1. You can send the packets, but can you get reply back from head office?
No,
Why?
we did not enter manually, right? But this 192.168.
Exactly. So
That's
head
why.
office routing table also will update network information because of to get reply 10 dot information is available here and 172.16 information is available in the routing table, but how 192.168 information is not there, so we cannot give reply. So head office routing table also we need to update manually which network information 192.168.1.0 is automatically updated, manually need to update
Manually.
Manually.
manually by using which method?
Static.
Static.
So code is yes, static. Now Branch 1, all LAN users. Head office, all LAN users. Traffic can come and reply will come back. So now between the two branches, communication we have enabled by adding networks in routing table manually. This method we call static routing method. Okay. The next example.
I have one dot Balu.
Yes, please.
We have to update those static IPs at the time of installation only or when the time of sending packet, all in table.
Once you update it, it will be permanently be saved.
So there is another static IP we have to update regarding that all number
Yes, of
branch office
course.
to also.
Yes. Yeah, that is my next
Yeah.
question actually. So now source is a branch 1,
Yeah.
destination is a branch office 2. Branch office 2 first compute is my destination. This is the source and is the destination. Now you tell me guys, your IP packet to reach to branch to LAN, what network IDs I need to be update manually in my branch office 1 routing table?
192.168.2.1. 2.0.
That's enough?
17.
172.17 also.
168. Yeah, 17 network and
This one
168.
serial one also we need to update.
Yes. 172.17 is also is not available here. So 172.17 need to update and 192.168 2.0 update, right? Let me update it now. 172.17.0.0, 192.168 2.0, both are manually need to be update or automatically update? Manually by static routing. Now branch office 1 and branch office 2, will they communicate?
We have to
Yeah.
update.
Update over there also, routing table 3.
Exactly. So we need to update in branch office 2 routing table also. We can send the packets, but can you get reply from branch 2? No. So what
No.
networks need to update here?
16 dot network,
16 dot network,
172.16,
168.
192.168.
1.0. Now branch 2 to head office want to communicate. Then which network need to be updated here?
10.0.0.
Dot
10.0.0.0.
0.
Head office to branch 2?
192.168.2.
Now all branches can start doing communication. So these all red color network IDs. As a network administrator, we need to be update manually.
Why we
This is
have
a
to enter manually? It won't take automatically.
we are implementing which type of routing here?
Static routing.
Then you have to update manually. If you implement dynamic routing protocol, then automatically come update.
Yeah, dynamic will automatically come, I know. And
Okay.
static also. Okay. Yeah.
Yes. So the same thing, branch 1, 2, 3, 4, 5 have a 50 branches or a 60 branches, same thing like this actually. So in branch office 1, first you need to find out where is your destination. If your destination is the head office, like in between what interface are missing, update here. If your destination is a branch 2, what networks is missing, update here. If destination is a branch 3, branch 4, branch 5, between all the networks we want to make a list and configure in branch 1, we can make it update. Same for head office, same for branch office too. Clear? Like after some time, one new branch I have added in my network existing topology, branch of history I want to add. Have connected branch of history router also. Let's consider branch of history router network is 9.0.0.0. So this 9.0.0 information on where on which routing table we need to update now?
For all routing tables.
In branch 1 it will be update, in head office, in branch 2 also. Not only that, like all branches network information will be updated in which router? Branch 3 router also.
Branch 3.
Yes. So this is the point in static routing. So static routes are configured, maintained, and updated by network administrator manually. And to configure static routes, we should know destination, right? Like administrators should know the destination IP addresses to for configuration. The 2 points are very important point. So try to read once again. If you are not getting, let me know it. So static routes are what? Configured, maintained, updated by network administrator manually. Maintenance means what? Like if any router is been down, like we don't have any update, we need to check it out manually. If any new router is added, no automatic updates, manually how to update. No, that is. An administrator should know IP address. Like these all the IP addresses we know, we should know to configure. These are the points. And administrative distance for static route is 1. So what is administrative distance? I'll discuss later it. Just you remember, AD value for static routing is 1. So administrative distance we'll discuss in dynamic routing protocol sessions. Clear?
Value on that.
Yeah, please.
If any one of the static IP is manually we didn't update, so when we're trying to send the package, it will got any error or we have to check where it is missing.
We have to check that.
We have to check manual, but it didn't
Yes.
show where the which router had been missing the.
Yeah, if we do the trace route, we can come to know where the traffic is dropping.
Okay.
Yes.
But it won't show any dialog box where it is dropping.
Like it don't shows the dialog box like in branch office 3 information is not like that actually.
Okay, okay. We
If you
have
are
to
if
check
you're trying to
manually.
reach destination, if you trace through, then up to where you're reaching it shows. That's it.
Okay. Still we are using this method static.
Yes, we are using.
Okay. If company has more branches, it is difficult to add all the IPs to
Yes, that is the main point. What if company has a small like company has small networks then?
small networks we can add manually.
That is the main point. Static routes are recommended to use for small networks only.
Okay.
So if it's a medium and large networks, obviously we'll go for dynamic routing protocol. Because of in static routing, network administrator work is more, task is more because everything we need to be update and we should know network IDs. You know, if
But
any new network is added, again we to update. Yeah,
we can use dynamic in small also, no? No problem.
that is what you should know. What if you use dynamic routing protocol in small networks? What advantages, what drawbacks you can get? If you
Okay.
know that, then you can decide.
Okay.
Similarly, static routing, if you implement the small networks, what is advantage you can get? If you implement static routing in medium and large networks, what drawbacks you can get? If you know that, then you can have a clear idea about where you need to implement static routing and where you implement dynamic routing. Okay,
Okay.
we'll say that, no problem. Right, we'll continue with configuration, static routing, how to configure it. Router global configuration mode, IP route, destination network ID, destination subnet mask, and exit interface type and number. Is the syntax. This is static routing configuration, guys. In global configuration mode, IP route, destination network ID. Whatever you have the destinations, that network IDs along with the subnet mask. Destination network ID, destination subnet mask, and where your traffic is exiting, on which interface your traffic is exiting, and that number. We'll see example of R1, branch 1 router. So branch office configuration mode, IP route. What are the destinations for branch 1? Static routes are destinations, right? So 10.0 is one destination, 172.17 is destination, 192.168 one destination. So first network is 10.network. IP route 10.000, 255.000. So to reach 10.network, this is LAN. LAN is 10.network, right? So to reach 10.network, from branch 1 traffic is generated, will come to fast Ethernet. I mean, where exactly from branch 1 traffic is exiting out? From branch 1 router, where traffic is exiting? On which interface traffic is exiting? To reach 10.network.
Serial.
Serial. Serial port number?
0 by 0.
That is 0/0/0. That is the syntax. So to reach 10.network, the traffic should exit on this interface. So to reach 10.network, your traffic has to exit via this interface. So we are defining manually. Why? Maybe have a one more route, like you have a another path is there. This is one more link is there. This is S1. But our destination is what? 10.network. So to reach 10.network, your traffic should exit via S000. Means traffic is directing like this. Okay, right. Now, how to reach 172.17 network from same source? If destination is 172.17, where your traffic is exiting out? On which interface?
0.1, 001.
Yeah, I can say this. So example, this is your room number 1, room number 2, room number 3, room number 4. No, this is your garden. These are the doors. Right. So now I'm in a room number 1. I'm here. From room number 1, my destination, I'm trying to go to room number 2. Where I'm to exit first? What is my exit point?
Room 1.
Room 1 door, right? This is your exit point. Okay. If my destination is I'm trying to reach to room number 3, what is my exit point? I'm in room number 1. My destination is room number 3. So where do I need to exit first?
Room 1.
Room 1.
One.
Yes, if my destination is the garden, I'm trying to reach the garden. Now I'm in room number 1. So where am I to exit first?
Room 1.
Room
So to reach any destination, to reach a room 2 or 3 or 4 or garden, like first exit point is what? Room number 1 I have to exit, right? Yes, the
Yeah.
same thing. Now from branch 1, if your destination is a 10 dot network or 192.162 dot network or 17 dot network, like any destination, where is your first exit point?
192.168.1.
S0000. This is your exit point. So to reach 10 dot network, traffic has to exit from this serial 0 ni. Like to reach 2 dot network also, first exit point is what? 00. That is. So next line, to reach any destination, like a 172.17, 0.0, 255.255.0.0, serial 0/0, like this. So one more example. Now source is a head office LAN. I'm in head office LAN. My destination is branch 1 LAN. What is my exit point? Where is my exit point?
Yes, 0, 0.
Head office land.
Head office.
Head office?
S001.
Yeah, from head office LAN, if your destination is branch 1, then exit point is what?
S001.
S001. Head office LAN is my source. Branch 2 is my destination. Then what is the exit point?
0, 0, S 0, 0.
S000. Like this. So something manually we are defining how your packet has to be exit to reach the destination. That is static routing actually. You know? Yeah. Let me implement on routers. So branch 1, show IP route. So present we have only 2 directly connected networks. Now we need to update 3 static routes. 1, 2, 3. Like how to reach serial how to reach 10 dot network? What is the exit point?
0,
S0
0.
slash 0 slash 0.
Serial
How
is
to reach
0, 0.
172 to 17? How to reach 192.168.2.0? Same exit point.
Serial 0, 0.
Yeah. Now how to reach 1.0 from head office?
0, 0. 0. 1.
1. Serial 0 slash 0 slash 1. How to reach 2.0? From branch 2 to head
1.
office or branch
Serial 0,
office
0, 1.
for all destinations same. Like let me configure now. IP route 10.000 255.0.0 serial 0 slash 0 slash 0. One network is updated. Second network IP route 172.17.00 255.255.0 serial 0 slash 0 slash 0. 192.168.2.0, 255.255.255.0, serial 0/0/0. So this is branch 1 static routing configurations. Now if we check routing table, show IP route. So SSS statically 10. Network updated. How to reach 10. Network via S000. How to reach 17 to 17 via S00. So whenever this user is trying to communicate with 10. Network, so source is 1.10, destination is 10.10, traffic will come to router. What router will do? Oh, you are trying to reach 10. Network. Let me check my routing table. Like how to reach 10. Network? Okay, via S00. Then traffic is sent to via S00. S00 head office is there. It can come. Is a method. Now, whenever the first user is communicating with 2.10, so 1.10 is a source, 2.10 is a destination. Packet is generated. It'll come to router. What router will do? We'll check the routing table. How to reach 2. Network? How to reach 2. Network? Okay, I have to send traffic via S00. So we'll send the traffic to S00. It'll come to head office. What head office will do? How to reach 2.0 via S00. Head office will forward to via S00. And how to reach 2.0? Like 2.0 on which interface? Fast Ethernet. It'll send to on fast Ethernet. It'll commit. So every router will forward the packet or switching the packet based upon routing table information. You just remember that what router will do whenever traffic will come to router, what router will do? Directly will look into routing table. If routing table, if the destination information is available, based upon that information, switching and forwarding. If destination is not there in routing table, what router will do? It simply drop the traffic. Like example, like 1.10 user is communicating with a 9.0.0.10. So source is 1.10, destination is 9.10. Packet will come to router. What router will do? Okay, you're coming from 1.10. Okay, where to reach 9. Network? It's checking the 9. Network. Do you have the 9. Network, my routing table? No 9. Network. Sorry, I'm dropping for traffic. Because of router don't know how to reach 9. Network, is dropping the traffic. So now your router, I mean branch office router can forward the traffic if your destination is a 10. Network. If your destination is a 172.17, if your destination is a 2. Then only your packet is being forwarded. If other than this network, if you have any destination, your traffic is been dropped. Okay, right. Now head office router configuration. 3 directly connect networks, 2 static routes, 192.168.1.0, 1.0, 255.255.255.0. Serial, how to reach 1.0? S001. How to reach 2.0? S000. So serial 0/0/1 and 2.0 via S000. So this is head office static routing configuration. Last branch 2. 2 directly connect networks. Now we need to be update static routing. IP route 192.168.1.0, 255.255.255.0, S001, 172.16.00. Head office LAN. Says branch office 2. Static routing configuration. Yes. Now if we check show IP route, static is updated. Now I can ping to head office network 10.0.0.1, and I can ping to branch 1 network also 1.1. Yes. But you try to check the communication from LAN to LAN devices. Means from PC1, click on the PC1, desktop, assign IP configuration as per conditions. Should be in the same network 1.10, gateway 192.168.1.1. Now head office computer. What is head office LAN network? 10.10, 10.0.1. Now if we check communication from branch 1 to head office, that should be communicated actually. No, successful. Same like for branch 2 also. It's clear? Anyone? All of you? Any doubts? Yes, please. Any doubts?
No, Balu.
Yeah, okay.
No, sir.
All right, you try to practice on this topology with static routing. And if you have any doubts, tomorrow we'll discuss about it. Thank you.